What is the history of ID3, C4.5, and CART decision tree algorithms? Imagine trying to decide what to do next based on what you already know. That's what decision tree algorithms help computers do. They are tools in machine learning that make decisions by splitting data into groups. These algorithms have a fascinating history that shows how they evolved to become powerful tools today. The story begins in the 1960s when researchers started exploring ways for computers to learn from data. But the real breakthrough came in the 1980s with Ross Quinlan. He developed the ID3 algorithm in 1986. ID3 was one of the first algorithms to use information theory to build decision trees. It works by choosing the attribute that gives the most information gain, which means it best separates the data into different groups. ID3 was great at handling categorical data, which means data that falls into specific categories like yes or no. It used a top-down approach, splitting data at each step to make the tree smaller and easier to understand. But ID3 had some limits. It was sensitive to noisy data, which can cause mistakes, and it didn't handle continuous data well. It also didn't prune the tree, so it could overfit the data, making it less accurate on new data. To fix these issues, Ross Quinlan created C4.5 in the early 1990s. C4.5 improved on ID3 by allowing the algorithm to handle both categorical and continuous data. It also introduced pruning, which removes parts of the tree that don't improve accuracy. This made the trees more reliable and less likely to overfit. C4.5 could also deal with missing data and different costs for attributes, making it more flexible. It became very popular and served as the basis for later versions like C5.0, which added features like boosting to make the trees faster and more accurate. Meanwhile, in 1984, another important decision tree algorithm was developed independently by Leo Brayman and his team. This was the CART algorithm, which stands for classification and regression trees. Unlike ID3 and C4.5, CART was designed to handle both classification tasks, like sorting emails as spam or not, and regression tasks, like predicting house prices. CART uses a different way to split data, called Gini impurity for classification and least squares for regression. It always creates binary trees, meaning each split divides data into exactly two parts. This makes the trees simple and easy to understand. CART also includes pruning methods to avoid overfitting, similar to C4.5. Its ability to handle continuous data and produce binary trees made it popular in many real-world applications. All these algorithms mark important steps in decision tree research. They each brought new ideas to improve how computers learn from data, handle different types of data, and avoid overfitting. They are the foundation of many machine learning systems used today in finance, healthcare, and more. Understanding their history helps us see how decision trees became such a vital part of artificial intelligence and machine learning. These algorithms show how simple rules can be combined to make complex decisions, and they continue to influence new tools like ChatGPT, DALL-E, and Midjourney, which build on these core ideas. They also help make AI systems more transparent, so we can see how decisions are made, which is very important for ethical use.